Okay, this video is part one in a set of two about solving systems of equations using elimination. So this is our third and final method of solving systems. This is my favorite. I tend to use this most of the time, more so because it works in pretty much any situation. We said with graphing, we only really use that if the directions tell us to graph, or maybe if we have like Desmos or some other technology, because we don't know if it's going to work out to be a nice intersection on the graph when we do it. Okay, substitution works really well when we either have y equals or x equals in one of our equations, or if we don't have that, okay, it's at least easy to get an x or y by itself if we do a little rearranging. Here, like I said, this works for everything. And in the ones where it might not look like it works, we can manipulate our equations to make it work, essentially. So hence why it works all the time. So I will say equations should be in the same form. So either both in standard form, that's when your x's and y's are on the same side, or both in slope-intercept form. If they're not, before you start using elimination, you should make them look the same. Honestly, okay, standard form, oops, sorry, computer fell. A standard form is easier to kind of move around into usually. And that's when x's and y's, I'm just going to make up a number, like something like this. So x's and y's are on the same side. That's best. Okay, but you can do it if there is slope-intercept form. I think that just takes a little bit more work. Okay, so here we are looking at 2x plus 3y equals 11 and negative 2x plus 5y equals 13. And it's important to note that if we're looking at the x's, we have a 2 as a coefficient and a negative 2 as a coefficient. And those are what we call opposites. Okay, opposites in math are the same number, but positive and negative. And what's important about opposites is opposites add to 0. Okay, so this might seem a little bit strange, but what we're actually going to do is we're going to take our two equations and we are going to add them together. So I like to draw a giant plus sign on the outside of my second equation, and I'm going to add my two equations together. And what's nice about that is when I add 2x plus a negative 2x, they add to 0 and they're gone. They're eliminated, hence elimination. And now we're going to keep on going. 3y plus 5y is 8y. And then 11 plus 13 is 24. We add all the pieces together, the x's, the y's, and the constants. And now that my x's are eliminated, I'm just left with 8y equals 24. And I would divide both sides by 8 and figure out that y equals 3. But remember, that's only half the answer. Okay, we now need to go do some work to figure out the x value. And this is where, okay, to find x, I'm going to make a note here, plug y into one equation. It does not matter which one, okay? I tend to look to see, hey, does one of my equations have smaller numbers? Okay, is one equation have less negatives than the other? Okay, so here I would probably say the first looks a little bit better, but once again, it does not matter. But what I'm going to do is up here, I'm going to rewrite my equation. And we're going to take the y that we just got and plug it in. I love my arrows on this, you know that, for the y in that equation. I could have done negative 2x plus 5y equals 13. I chose 2x plus 3y equals 11. So 2x plus 3 times 3 equals 11. We're going to do that itty bitty teeny bit of math right there. So 2x plus 9 equals 11. And now it just looks like a normal two-step equation that we have to solve. So we would subtract 9 from both sides, get 2x equals 2, and then divide both sides by 2, and x equals 1. And our final answer should be an ordered pair. And in this case, x was 1 and y was 3, and that should be our answer. So once again, if your x's or your y's, it doesn't matter which one, if one of your variables has coefficients that are opposites, We're going to add the equations together, which eliminates one of our variables. We solve for what's left, and then we plug it into one of the equations to figure out the other variable that we eliminated in the first place. Okay, let's try a different one. Here, when we're looking at this, they don't match. We have 3x equals negative 3y minus 27, and 8x minus 3y equals negative 6. The bottom one is in what we call standard form, where the x's and y's on the same side. The top one is not. I have my x's on the left, but my y's on the right. Okay, so it's actually not in any form. But I'm just going to manipulate that equation, okay, so that it matches the one on the bottom. And really what I want to happen is I want the y's on the right-hand side to get over to the left-hand side. Okay, so I need to move them over, and to do that, because it's a negative 3y, I'm going to add 3y to both sides. Okay, so obviously I run out of room there, so I'm just going to write it on the side. So 3x plus 3y equals negative 27, and then 8x minus 3y equals negative 6. And now they match, and now I can see I have a positive 3y and a negative 3y. Those are opposites. So I'm going to add my two equations together, which cancels out. Well, I shouldn't say cancel, but it makes my y's add to 0. So they are eliminated. 3x plus 8x is 11x. Negative 27 plus a negative 6 is a negative 33. I will say you have to be careful of your integer rules when doing this lesson. And then divide by 11, and x is negative 3. So now I need to plug it into one of my two equations. It does not matter. I can use this one over here. I can use this one. I can use this one. Okay, any of them. Okay, I'm going to choose that 3x equals negative 3y minus 27. Doesn't matter. And now that x is negative 3, we're plugging it in there. We do that itty bitty math right there. So negative 9 equals negative 3y minus 27. Two-step equation. We add 27 to both sides. That would be 18 is negative 3y. And then we divide by negative 3, and y is negative 6. And final answer, x was negative 3, y is negative 6. That is my ordered pair. Okay. We're going to do one more. This one is a little bit different. So here, when we're looking at it, x and y have the same coefficient. And you have two options. Okay, the first option is, well, before, because they were opposites, we could add them to eliminate something. Here, we could technically subtract the one equation from the other one, because 3y minus 3y would eliminate them. However, this gets tricky, especially with our negatives, because you have to subtract the bottom from the top. So we have minus and negatives thrown in there. My suggestion, okay, let's try option 2. Okay, option 2. Okay, the first two we did were not so bad. Option 2 is change all the signs of one equation. Essentially, you're just multiplying the entire equation by -1. Okay, but change all the signs of one equation. And when you do that, you will have opposites now. And then we can just do exactly what we did above, where we add them together. And honestly, guys, adding your equations is so much easier than subtracting them. Okay, trust me. Okay, so we're going to change one of them. So how about we take this top one and change all the signs. So we're going to make it negative 4x minus 3y equal to -2. Okay, and then the second one's going to stay the same. So 5x plus 3y equals -2. And now I have my negative 3y and positive 3y. I can add my two equations together. My y's are eliminated. We have negative 4x plus 5x. That's nice. That's just x. And then -2 plus a -2 is a -4. And now we're going to take that and plug it in. I'll do the first one again, but once again, it does not matter. 4x plus 3y equals 2, and we're taking our x and plugging it in there. So 4 times -4 plus 3y equals 2. Do that itty bitty math. -16 plus 3y equals 2. And then I would add 16 to both sides. 3y equals 18. Divide by 3, and y equals 6. And final answer, -4, 6. Okay. So that is how the general steps of our elimination. Okay, we can have some slightly harder questions, which is what the next video will cover. But for now, we should be able to either add our equations together, subtract them, or like I said, instead of subtracting, change the signs of one equation, and then you can just add them, just like we did in the first two.